Okay, this was sine. I'm going to move it out of the way for a second, and we'll do a similar thing for cosine. You need two things. You need to think about, for that triangle, I guess I should get those triangles back here. For these triangles, if we're looking at now the angles related to 30, what are we looking at if we want 30 degrees? If we want cosine now, we're still looking at that. So we don't need this triangle for this one. But if we're looking at cosine, which values are involved here? Cosine of that is this one over this one, adjacent over hypotenuse, right? So if you know that, and you know that for all of these angles, they're going to have the same absolute value, like the same number part for the trig ratio. It's just going to be positive or negative depending on which quadrant you're in. So as long as you know which quadrant cosine is positive, so this is cosine now, cosine with one S, cosine. Where is it positive? Where is it negative? Cosine doesn't track the y coordinate. Like if you have an angle here, cosine is this value over that. So whether this is a unit circle or not, it tracks the x coordinate. So cosine is positive or negative where x is positive or negative. Okay? X coordinate. So where is the x coordinate positive? Well, when you're on the right side here, right? This is where the x coordinate is positive. And then this is where it's negative, over here. So as long as you know that cosine is positive, whether you know it for how you learned it in grade 11, you know, the all students take classes or whatever, it's positive over here and it's negative over here. Okay, whether you should know it from several ways, right? You should know it's related to the x coordinate. And then you know that it's the number part's going to be root 3 over 2. There it is, right? Root 3 over 2. All of them are root 3 over 2, except some of them are not. Some of them are negative root 3 over 2. Which ones are negative? Yeah, those two, right? I think this ends up, people think it's harder than it is. There's not a lot of numbers that are going to come up. 1/2 is going to come up. Like, think about the ratios you can come up with out of those two triangles. There's not a lot of different numbers you can come up with, right? Right? If you use those two triangles, here's the numbers you can come up with. You got a 1, 1, root 2, or you have a 1, root 3, 2 triangle. If you're talking about sine or cosine, the sine of this is 1 over 2. Right? So you can come up with 1 over 2 is one of the numbers that's going to happen. You can come up with the other one we did there, root 3 over 2. But if you're talking about sine or cosine, those are the only numbers that are going to come up. And then the only other one, what would the sine and cosine of 45 here be? You'd have to use this triangle because that's the one that has 45 in it. Yeah, it'd be 1 over root 2. Okay? 1 over root 2. For sine and cosine of those three angles, that's all that's going to come up. And then all the ones related to that you can write out. So I've given you a table like this for each of them. I gave you a picture with the 4 angles. So you should actually draw the angles on there. I know I went like this and just did that for you. But you should actually draw the angles and say, there's the first one, there's the second one, there's the third one, and there's the fourth one. Because you're measuring it from 0 all the time. You should probably write down in degrees or in radians. This is pi over 6. What is this? Yeah, if you want the quick way to think about that is either you think, oops, that's really useful pen. Either you think if this is 30, I think most of you probably are going to think in degrees for a while, and you're going to think pi over 6 is 30 degrees. If that's 30, what's over here? If this was 30, how many other degrees are there? 150, right? If you want to think in radians, you just think in fractions and think, if this was 1/6 of pi, and I put it over here, if I had 1/6 there, how many sixths are left over there? It's 5/6, right? Or if I was thinking in quadrant 3, if this was 1/6 of pi, how many would that be all the way around to there? It would be 7/6, and then the last one's 11/6. So you're going to go through and do this activity where you're filling them all in. And then once you get the hang of it, here I was just thinking you were going to list the angles related. Some of you I realize might know that already. 5 pi over 6, 7 pi over 6, that's all I was thinking you were doing. And then you're actually filling in the ratios for angles related to 30 degrees. And so there's the picture, there's the one we just did. It might help you to write down the degrees next to it. I think it might. 30, 150, and so on, right? And 5, I was thinking you would fill these in. And then just write the ratios. Don't stare at this for 10 minutes. It's not that hard. We just did it actually, so certainly don't stare at that one. Don't stare at this one for that long either, because it's different angles. You got to draw the picture here, but you're going to be able to fill in the ratios pretty quick. And then 45, and then you can start to summarize it for yourself where I put them all together here. Okay, so you're writing the sine and the cosine for all of those within 0 to 90, and then it's just kind of restating it here. Draw and label all the angles related to pi over 6 and pi over 3. And then draw all of them related to pi over 4. It's redoing the activity. You don't actually have to go through and do that if you want. I think you're going to be okay with this. Don't get hung up on filling in everything. The goal of this, remember, is to be able to, and at the end of this we're going to do this. We'll test you just before lunch. Okay? We're going to test you just before lunch. I'm going to say things like sine of 120, and you and the person next to you are going to kind of compete to see who can come up with it quicker. Okay? We'll keep score and stuff. That's how you're going to test yourself. So you have to learn it first. I don't really care if you... Please don't approach this from, oh, I have to fill out all the boxes. Approach it from, I need to learn it. Now, I put all these things in here to help you learn it, but whatever, right? I mean, work through it and try and learn how to write the exact value for different angles if, just using those triangles. Okay? So it was far longer than I said it was going to be.